Hello everyone, and welcome to this in-depth video on the Arduino Uno Rev3. Today, we'll be taking a detailed look at each component and feature of this versatile microcontroller board. So let's get started. First, let's talk about the built-in LED on the Arduino Uno Rev3. This LED is connected to pin 13 and can be controlled using the microcontroller. It's often used as a visual indicator in projects or for basic output testing during development. Moving on, we have the 16 MHz resonator. This component provides the clock signal for the Arduino Uno Rev3. The clock signal determines the speed at which the microcontroller executes instructions and helps synchronize various operations. Next, we come to the ICSP, in-circuit serial programming, header for the 𝗗𝗙𝗪𝗡𝗟𝗢𝗪𝗡 microcontroller. This header allows you to program the microcontroller using an external programmer or another Arduino board. It provides an interface for uploading your code and updating the firmware of the microcontroller. The Arduino Uno Rev3 also includes a crystal oscillator. This oscillator provides precise timing for the microcontroller. By maintaining a consistent oscillation frequency, the crystal oscillator ensures accurate timekeeping and synchronization of the board's functions. Now, let's focus on the heart of the Arduino Uno Rev3, the 𝗗𝗙𝗪𝗡𝗟𝗢𝗪𝗡 microcontroller. This microcontroller is based on the AVR architecture and is responsible for executing the instructions of your program. It contains the central processing unit, CPU, memory, both flash and SRAM, and various peripherals for input-output operations. Moving on to the pins, let's start with the analog inputs. The Arduino Uno Rev3 has 6 analog input pins labeled A0 to A5. These pins allow you to read analog voltage levels from sensors or other analog devices. They are essential for interfacing with the physical world and acquiring analog data. Next, we have the voltage in and ground pins. The voltage in pin is where you connect the power supply to provide the necessary voltage for the board's operation. The ground pins are used as the reference point for electrical circuits and complete the power circuit. The Arduino Uno Rev3 features a 5V power pin and a 3.3V power pin. These regulated power outputs allow you to provide power to other components or modules in your project that require a specific voltage level. It provides a convenient and stable power source for your connected devices. Now, let's talk about the reset pin. The reset pin allows you to manually restart the microcontroller. By momentarily pulling this pin to a low voltage, you can reset the microcontroller, restarting your program execution from the beginning. To ensure stable power supply and protection, the Arduino Uno Rev3 incorporates a 3.3V regulator, an external power supply input, and a 5V regulator. The 3.3V regulator ensures that the microcontroller receives a stable 3.3V power supply, while the 5V regulator provides a regulated 5V power output for other components or modules connected to the board. These regulators help protect the board and its components from voltage fluctuations and overcurrent situations. Now, let's discuss the LM358. The LM358 is an operational amplifier, op-amp, that can be used to amplify or condition analog signals in your projects. It provides flexibility in processing analog signals and is commonly used in various applications such as amplification, filtering, and signal conditioning. For added safety, the Arduino Uno Rev3 incorporates a polyfuse. A polyfuse is a self-resetting fuse that protects the board from excessive current. If the current exceeds a certain threshold, the polyfuse temporarily opens the circuit, cutting off the power supply. Once the fault is resolved and the current returns to a safe level, the polyfuse resets itself and restores the power connection. To connect the Arduino Uno Rev3 to your computer or other devices, you have a USB TTL converter and a USB plug. The USB TTL converter allows you to establish a serial communication link between the microcontroller and your computer, enabling you to upload code and communicate with the board. The USB plug provides the physical interface for connecting the board to a USB port. In addition to the ICSP header for the 𝗗𝗙𝗪𝗡𝗟𝗢𝗪𝗡, there's also an ICSP header for the 8MEGA16U. This header is used for programming the 8MEGA16U, which is responsible for handling the USB communication on the board. It allows you to update the firmware or make changes to the USB functionality of the Arduino Uno Rev3. The board features a reset button, which provides a convenient way to manually reset the microcontroller. By pressing the reset button, you can initiate a reset and start your program execution from the beginning. Now, let's discuss the analog reference pin. The analog reference pin, labeled ARF, is used to provide a reference voltage for the analog to digital converter, ADC, on the board. By connecting a known reference voltage to this pin, you can accurately measure and convert analog signals into digital values. Next, we have the digital ground pin. This pin provides the ground reference for the digital components on the board. It ensures that the voltage levels and signals for digital operations are correctly referenced and stable. Finally, we come to the digital I/O pins, numbered from 2 to 13. These pins can be used for both digital input and output operations. They allow you to interface with a wide range of digital devices and components, such as sensors, actuators, displays, and communication modules. Additionally, the Arduino Uno Rev3 has a serial out pin, TX, and a serial in pin, RX, for serial communication. These pins are used for data transmission and reception between the board and other devices or modules, such as a computer or another Arduino. That concludes our detailed overview of the Arduino Uno Rev3 and its various components and features. I hope you found this information helpful for understanding the board's capabilities. Thank you for watching, and stay tuned for more Arduino tutorials and projects.